November 1942. The jungles of Guadalcanal. A Japanese patrol moves through the dense undergrowth. The air is thick with humidity and the smell of rotting vegetation. Suddenly, the green canopy erupts. A hail of lead tears through the trees. The sound is relentless. It is a continuous, rapid hammer of gunshots. To the Japanese officers leading the patrol, this is not a common infantry skirmish. It is an ambush by a heavy machine gun nest. Therefore, they order their men to retreat and call for heavy mortar support to clear the path. But they were wrong. There was no machine gun nest in the jungle ahead. There was only a single squad of standard American infantrymen holding the line. Many history buffs believe that the Pacific War was won solely by massive aircraft carriers, strategic bombers, and raw industrial numbers. But on the muddy ground of the islands, the war was decided by the individual soldier's rifle. For decades, conventional military history has stated that the Imperial Japanese Army possessed the most disciplined, spiritual infantrymen in the world. They were trained to conserve ammunition, move in absolute silence, and strike with long-range precision. Yet when these elite forces encountered the standard-issue American rifle, their tactical doctrine shattered. Japanese commanders sent urgent, classified reports back to Tokyo, claiming that every single American soldier carried a light machine gun. This is the story of how a mechanical breakthrough created a terrifying illusion of infinite firepower, and how the empire desperately tried to copy it before their industrial machine collapsed. To understand why Japanese officers misidentified American squads, one must first look at the weapon in their own hands. The story of the Japanese service rifle began in the late 19th century, as the Empire of Japan sought to modernize its feudal army. Colonel Nariakira Arisaka was tasked with designing a rifle that could match the smokeless powder technology of Western empires. His early designs led to the Type 30 Marauder rifle, which was used during the Boxer Rebellion. But it was during the Russo-Japanese War of 1904 that the Japanese military realized their infantry weapons needed a complete redesign. The dust of the Manchurian plains caused constant failures in the early actions. Therefore, the legendary designer Kajiro Nambu took Arisaka's design and refined it into the Type 38 rifle. This weapon was chambered in the flat-shooting 6.5mm Arisaka cartridge. This cartridge was chosen for a very specific reason. It had low recoil, allowing the small-framed Japanese soldier to maintain high accuracy during rapid fire. But in the late 1930s, during the invasion of China, the Japanese military realized that this smaller caliber lacked stopping power at long ranges. Therefore, they developed the Type 99 rifle, chambered in the more powerful 7.7mm caliber. The Type 99 Arisaka was a mechanical paradox. On one hand, it was an incredibly strong, over-engineered piece of military hardware. The receiver was forged from high-tensile chrome vanadium steel at the Yokosuka Arsenal in Tokyo. This steel was of such high quality that the Arisaka bolt action was widely considered the strongest action of the Second World War. It could handle chamber pressures that would physically rupture a German Mauser or a British Lee Enfield. Furthermore, the barrel of the Type 99 was chrome-lined. This was a revolutionary engineering choice. Japan was the first nation to chrome-line its military rifle barrels. They did this because they knew their soldiers would be operating in the humid, saltwater environments of the Pacific. The chrome lining prevented rust and corrosion, maintaining accuracy even when the rifle was subjected to weeks of rain and mud. But this focus on durability was balanced by design choices that were completely obsolete. To protect the action, the designers included a stamped sheet metal dust cover that slid along with the bolt. In theory, this kept mud and sand out of the receiver. But in practice, the cover was a disaster. The thin metal would warp, causing the bolt to jam. Worse, every time the soldier cycled the action, the cover would slide with a loud, metallic screech. In the quiet of a night patrol, this sound warned enemy scouts of the Japanese position. Therefore, many frontline soldiers simply threw the dust cover away as soon as they reached the combat zone. The rifle was also equipped with a wire monopod attached to the wooden stock, meant to stabilize the weapon when firing from the prone position. But the thin wire bent easily in the mud and caught on vines. Therefore, it too was discarded. But the most bizarre feature of the Type 99 Arisaka was its anti-aircraft sights. The rear sight featured two folding metal wings. These wings were designed to help the individual infantryman lead a low-flying Allied aircraft, allowing a squad to fire a coordinated volley at a plane. It was a tactical concept born of desperation. An infantryman standing in a muddy trench, trying to hit a fighter plane flying at 300 miles per hour with a bolt-action rifle, was a statistical impossibility. This design reflected the core weakness of the Japanese military philosophy. They treated the rifle as a craftsmanship project rather than a mass production tool. Every Arisaka bolt was hand-fitted to its specific receiver. This meant that if a bolt was lost in the mud, you could not simply grab a bolt from another rifle and insert it. It would not fit. This lack of parts standardization was a logbook nightmare for Japanese mechanics. The rifle was a 19th century weapon, built with 20th century steel. It was slow, manual, and demanding. And this manual slowness was the baseline expectation of the Japanese command. They believed all combat was bound by the rhythm of bolt-action fire. They were completely unprepared for the mechanical reality of the American gas-operated piston. While the Japanese military refined their bolt-action rifles, the United States was embarking on a radical experimentation program. In the early 1930s, the U.S. Army was searching for a semi-automatic infantry rifle that could become the standard-issue weapon for every soldier. This was a task that European military powers had deemed technically impossible. Both British and German engineers believed that a semi-automatic action was too complex, too heavy, and too prone to jamming under battlefield conditions. But a Canadian-born designer named John Garand, working at the government-owned Springfield Armory, refused to accept this limitation. Garand was a master machinist. He understood that a military rifle had to be built for mass production. In 1932, Garand had completed a promising prototype chambered in the .200 and .76 Pedersen caliber. This cartridge was small, had low recoil, and operated at low pressures, making the semi-automatic action easy to design. But the Chief of Staff of the U.S. Army, General Douglas MacArthur, intervened. MacArthur looked at the massive stockpiles of .30.6 ammunition left over from the First World War. Therefore, he vetoed the new caliber. He declared that any new rifle must be chambered in the heavy, violent .30.6 caliber. This decision forced John Garand to scrap his designs and start from scratch. The .30.6 cartridge was incredibly powerful, generating pressures exceeding 50,000 pounds per square inch. To harness this energy without blowing the rifle apart, Garand had to design a rugged gas-operated system. His early production models utilized a gas trap at the end of the muzzle. This was a metal sleeve attached to the barrel that caught the gases as they exited the muzzle and redirected them to push the operating rod. But the gas trap was fragile. It was easily damaged in the field and accumulated carbon fouling rapidly, causing the rifle to jam. Therefore, in 1940, Garand redesigned the system. He drilled a small gas port directly into the barrel itself, just behind the muzzle. This gas port tapped a tiny amount of the gas to push the long steel operating rod back. This port design proved to be incredibly reliable, and it was this version that went into mass production. The heart of Garand's design was the rotating bolt with two locking lugs. When the operating rod traveled back, a cam slot in the rod rotated the bolt, unlocking it from the receiver. The bolt then moved back, extracting the spent shell while compressing a heavy operating rod spring. As the spring expanded, it pushed the bolt forward, loading a fresh round from the end-block clip. This end-block clip was a brilliant piece of engineering, but it required a specific loading procedure. The soldier had to push the 8-round steel clip straight down into the receiver with his thumb. As soon as the clip clicked into place, the spring-loaded bolt would snap forward with immense force. If the soldier did not pull his thumb out of the way quickly enough, the heavy steel bolt would slam closed on his flesh. This painful accident became known as Garand thumb. But despite this minor hazard, the rifle was a marvel of simplicity. It could be completely disassembled in the field without any tools in less than 10 seconds. It was designed for the average citizen soldier. It was simple, rugged, and fast. And it was this industrial machine that was about to clash with the handcrafted precision of the Arisaka. The strategic transition from this design phase to battlefield application occurred in late 1942 on Guadalcanal. The first units to land on the island, primarily the United States Marines, were actually still equipped with the bolt-action Springfield 1903 rifle. But as the U.S. Army Eurostrade S. American Division and the 25th Infantry Division arrived to reinforce the island, they brought the M1 Garand in mass numbers. The tactical clash that followed in the jungle was a revelation for both sides. In the dense undergrowth, visibility was often limited to less than 20 yards. Soldiers could hear the enemy moving through the brush, but could rarely see them clearly. Under these conditions, the traditional Japanese tactic of long-range precision shooting was completely neutralized. Therefore, the battle became a contest of rapid reaction and suppression. When a Japanese patrol encountered an American fire team, the Japanese soldiers would drop to the ground and attempt to cycle their bolts to fire. But before they could acquire a target, the American soldiers would unleash a torrent of semi-automatic fire. Every time a Japanese soldier fired one round from his Arisaka, the American soldier next to him could fire 4 or 5 rounds from his Garand. This difference was a force multiplier. It meant that a small American squad could establish immediate fire superiority, pinning the Japanese behind trees and log bunkers. Once pinned, the Americans could maneuver and destroy the Japanese position with grenades or mortar support. The psychological impact on the Japanese survivors was profound. They had never experienced infantry fire of such density. Therefore, their combat reports started describing American units as being armed with portable machine guns. They simply could not believe that standard riflemen could maintain such a relentless pace of fire without their weapons jamming or running out of ammunition. The mechanical efficiency of John Garand's design had successfully transformed a squad of ordinary riflemen into a devastating tactical asset. But the tactical value of the M1 Garand was not just tested in the humid jungles of the South Pacific. It was also proven in the freezing, mountainous fog of the Aleutian Islands. In May 1943, the United States launched an amphibious invasion to recapture Attu Island from the occupying forces of the Imperial Japanese Army. The U.S. Army's 7th Infantry Division was equipped with the semi-automatic M1 Garand. Meanwhile, the Japanese defenders, under the command of Colonel Yasuo Yamasaki, were dug into deep mountain caves armed with the Type 99 Arisaka. The conditions were brutal. The temperature was near freezing. The volcanic mud and wet tundra coated every piece of machinery. Many soldiers found that their weapons would clog and freeze. But the gas-operated system of the Garand, shielded by its heavy steel receiver, proved remarkably rugged. As long as the soldiers kept the operating rod clear of thick mud, it continued to cycle. The Japanese, on the other hand, struggled to manually cycle their bolt-action rifles with cold, frozen fingers. And this difference in mechanical capability would determine the final, bloody climax of the battle. By the end of May, the Japanese garrison was pushed back to the sea at Chichagof Harbor. They were out of ammunition, starving, and cut off from reinforcement. Therefore, Colonel Yamasaki decided to launch a final, desperate night attack. It would be the largest Banzai charge of the Pacific War. Over 1,000 Japanese soldiers, many armed only with bayonets on empty rifles or knives tied to sticks, charged through the dense fog. They overran the U.S. front line, screaming and charging in the dark. They penetrated deep into the American camp, reaching the rear support units, medical tents, and artillery lines. In the confusion of the fog, there was no organized front. Therefore, cooks, clerks, and engineers had to grab their M1 Garands and form a defensive line in the dirt. When the charging Japanese emerged from the mist, they expected to find a panicked enemy. Instead, they met a wall of semi-automatic fire. In the darkness, the U.S. soldiers did not need to cycle bolts. They did not need to pause. They simply fired as fast as they could pull their triggers, ejecting clip after clip. The rapid, continuous fire tore through the charging columns. The Japanese soldiers, relying on the spiritual power of the bayonet charge and the manual cycle of the Arisaka, could not close the distance. They were cut down by the dozens before they could reach the American line. Over 500 Japanese bodies were found in front of the rear camp positions alone. The Banzai charge, which had been a terrifying tactical weapon against bolt-action units in the early war, was completely broken by the fire rate of the Garand. It was the first major realization for the Japanese high command that spiritual willpower could not cross a valley swept by semi-automatic fire. But the war was moving south, and the next test would be even more claustrophobic. In November 1943, the United States Navy launched Operation Galvanic, targeting the tiny island of Batio in the Tarawa Atoll. The island was defended by 5,000 elite Japanese Special Naval Landing Forces. They had spent months building an intricate network of concrete bunkers, steel pillboxes, and log seawalls. When the Marines of the 2nd Marine Division landed, the tide was low. Their landing crafts ran aground on the coral reef, hundreds of yards from the shore. Therefore, the Marines had to wade through chest-deep water under a hail of machine gun and rifle fire. Many lost their weapons or had them soaked in salt water and sand. But as they reached the beach, they found that the M1 Garand, despite being filled with wet sand and salt water, could still be fired. Marines would cycle the first round manually to clear the chamber, and the gas system would continue to cycle the rest. The Arisaka, with its tight bolt tolerances, would often bind and lock up when fine sand entered the receiver. But the real value of the Garand on Tarawa was not just its reliability. It was its ability to suppress. On Batio, the combat was a yard-by-yard struggle to clear underground bunkers. A standard squad could not advance because Japanese soldiers would fire their Arisakas through narrow slits in the concrete. To move forward, the Marines had to use close coordination. This is where the semi-automatic fire rate of the M1 Garand became a lifesaver. A single Marine could stand behind cover and fire 8 rounds rapidly at a bunker opening. The continuous dust and impact of bullets forced the Japanese defender inside to duck and lose his sight line. Under this suppressive cover, another Marine would sprint forward with a satchel charge or a flamethrower. If the Marines had been armed with bolt-action Springfields, this tactic would have failed. The pause required to cycle the bolt would have given the Japanese defender the split second he needed to pop up and fire. But the M1 Garand kept the enemy pinned without a gap. The speed of the en-bloc clip reload allowed the Marines to maintain this pressure. Therefore, the concrete fortress of Tarawa was systematically dismantled, bunker by bunker, by fire teams using the Garand as a suppressive shield. The battle proved that in the brutal arithmetic of amphibious assault, semi-automatic fire was not a luxury. It was the foundation of tactical movement. This mechanical disparity on the battlefield was actually the physical manifestation of two completely opposing military philosophies. The Imperial Japanese Army operated under a doctrine of extreme resource scarcity. Japan was an empire with severe industrial bottlenecks and a lack of access to oil, iron, and coal. Therefore, their military manuals, such as the Field Service Code, taught that victory was not won by material superiority, but by spiritual power, which they called Seishin. Japanese soldiers were trained to believe that their spiritual discipline could overcome any mechanical obstacle. This philosophy dictated their approach to small arms. Ammunition was viewed as a precious resource that belonged to the emperor. Therefore, a soldier was expected to make every bullet count. Firing blindly to suppress the enemy was viewed as a waste and a sign of poor discipline. Instead, they were trained to wait, crawl close, and fire a single, lethal shot, often followed immediately by a bayonet charge. But the United States military operated under the doctrine of industrial abundance. The U.S. possessed near-limitless manufacturing power, massive steel foundries, and endless oil reserves. Therefore, American military planners did not ask their soldiers to conserve ammunition. Instead, they believed in fire superiority. Their doctrine taught that the best way to save American lives was to overwhelm the enemy with metal. If an American squad suspected that a Japanese sniper was hidden in a tree line, they did not send a scout to investigate. Therefore, they would simply order the entire squad to fire dozens of rounds into the foliage. They used their industrial capacity to solve tactical problems. This clash of doctrines created a profound psychological shock for the Japanese soldier. They found themselves facing an enemy that seemed to have an infinite supply of ammunition and a weapon that never had to pause to cycle a bolt. Every time the Japanese attempted a traditional night attack or a coordinated Banzai charge, they were met not by individual, rhythmic rifle shots, but by an unbroken barrier of rapid-fire lead. The spiritual willpower of the Seishin was physically shredded by the mechanical reality of the gas-operated piston. The M1 Garand was the ultimate expression of this American doctrine of abundance. It was a weapon designed to burn ammunition rapidly, because the U.S. logistical machine could easily supply millions of rounds to the front lines. But this rapid consumption of ammunition also created a unique vulnerability, which led to one of the most persistent legends of the Pacific War. This is the story of the M1 Garand Ping. For decades, military historians and veterans have debated the significance of the metallic ring made by the Garand's empty steel clip. The legend states that the Japanese soldiers learned to listen for this distinctive ping during close-quarters combat. According to the myth, when a Japanese soldier heard the ping, he knew the American was out of ammunition and had to reload. Therefore, the Japanese soldier would charge from his cover with a bayonet to kill the American before he could insert a fresh clip. It is a dramatic, cinematic story. But under the cold light of historical analysis and combat physics, it is almost entirely a myth. The first reason the myth falls apart is the sheer volume of noise on a battlefield. In the chaos of actual combat, a battle is not a quiet environment. There are artillery shells exploding, heavy machine guns firing, men shouting, and mortars bursting. The metallic ring of a tiny piece of spring steel hitting the ground or ejecting from a receiver is relatively quiet, measuring less than 80 decibels. But a single rifle shot exceeds 150 decibels, and an exploding mortar can reach 180 decibels. Therefore, physically hearing the ping from 20 yards away in the middle of a firefight was virtually impossible. Furthermore, American soldiers did not fight in isolation. They operated in coordinated fire teams. If one soldier's M1 Garand went empty, his squadmate next to him was still fully loaded and covering his reload. Charging a reloading American meant running directly into the fire of his teammates. In fact, declassified records reveal that some American soldiers actually turned this myth against the enemy. During quiet moments in patrol actions, a Marine would deliberately tap an empty steel clip against his helmet to create the distinctive ping sound. This would bait overeager Japanese soldiers into believing the American was reloading. Therefore, the Japanese soldier would expose himself from cover, only to be shot by the American who was holding a fully loaded rifle or a secondary sidearm. The ping was not a mechanical vulnerability. It was a psychological trap. The myth of the ping survived because it fit the romantic narrative of individual combat, but the reality of the war was decided by collective firepower and tactical coordination. And as the war entered its final phases, the Japanese high command realized that their spiritual doctrine was failing, forcing them to take desperate measures to copy the very technology that was destroying them. The viability of a semi-automatic rifle like the M1 Garand was not just a question of mechanical design. It was fundamentally a question of logistics. A semi-automatic rifle is a ravenous consumer of ammunition. Therefore, it is only as good as the supply line that feeds it. Without a constant, massive flow of ammunition to the front lines, a rapid-firing rifle like the Garand quickly becomes nothing more than a heavy club. And this is where the contrast between the United States and the Empire of Japan reached its most extreme point. The United States possessed the greatest logistical machine in human history. They built thousands of cargo ships, known as Liberty ships, to carry supplies across the vast expanses of the Pacific Ocean. They established massive floating supply bases, turning remote lagoons into bustling ports where warships could be repaired and resupplied without returning to Hawaii. For the American infantrymen on the front line, this meant that ammunition was almost never rationed. Supply depots were packed with crates of .30.6 ammunition. Every infantryman carried multiple canvas pouches, each holding an 8-round clip and additional bandoliers slung across his chest. They had the confidence that if they fired all their ammunition today, a fresh truckload would arrive tomorrow. But for the Japanese soldier, the reality was bleak. As the war progressed, the United States Navy's submarine campaign systematically destroyed Japan's merchant fleet. Japan could no longer transport raw materials from its conquered territories to its home islands, nor could it send food and ammunition to its garrisoned troops in the Pacific. The supply lines were completely severed. To survive, the Japanese military had to resort to desperate measures. They used destroyers known as the Tokyo Express to run at high speed under the cover of night, throwing metal fuel drums filled with rice and ammunition into the water near the beaches, hoping their soldiers could swim out and retrieve them. Most of these drums were lost or sunk. Therefore, the Japanese soldiers on islands like Guadalcanal, New Guinea, and Attu were starving. They had to ration their ammunition to a handful of rounds per man. Under these conditions, equipping their troops with a rapid-firing semi-automatic rifle would have been a disaster. They simply did not have the ammunition to feed it. The manual bolt action Arisaka was not just a tactical choice. It was a logistical necessity for a starving army. Yet by 1944, the high command of the Imperial Japanese Navy could no longer ignore the devastating impact of American fire superiority. They saw their troops systematically wiped out on every island landing. The gap in infantry firepower had become a chasm. Therefore, they decided to copy the M1 Garand. They recovered captured American rifles from the Philippines and sent them to the Yokosuka Naval Arsenal. The engineers were ordered to reverse-engineer the weapon and adapt it to fire the standard Japanese 7.7mm cartridge. This project resulted in the Type 4 semi-automatic rifle. At first glance, the Type 4 looked almost identical to the M1 Garand. It utilized the same gas-operated piston and rotating bolt mechanism. But the Japanese engineers ran into a critical metallurgical bottleneck. They could not reliably manufacture the spring-tempered steel end block clips that were essential for the Garand's loading system. Because of Allied bombing campaigns and the naval blockade, the quality of Japanese steel had severely degraded. The prototype clips they manufactured were too brittle and would snap, or too soft and would bend, causing constant jams in the receiver. Therefore, the engineers had to redesign the rifle's feeding system. Instead of using the top-loading end block clip, they built a fixed, 10-round internal box magazine. To load the rifle, the soldier had to open the bolt and insert 2 standard 5-round stripper clips, pushing the rounds down into the magazine manually. It was a slow, awkward process that defeated the primary speed benefit of the Garand design. Furthermore, the project was plagued by persistent manufacturing delays. The arsenals lacked precision machinery, skilled labor, and raw materials. Every part had to be hand-finished, which destroyed any hope of standardization. By the time the prototypes were ready for field testing in early 1945, the war was already lost. American B-29 bombers were systematically destroying Japan's cities and factories. Power grids were failing, and coal supplies had run dry. Only about 250 Type 4 rifles were ever assembled, and none of them ever saw combat. It was a tragic, desperate attempt to match the industrial might of the United States with handcrafted prototypes. The Empire of Japan had the scientific intelligence to understand the M1 Garand, but they lacked the industrial power to build it. The failure of the Japanese Type 4 rifle program was not just a failure of a single weapon system. It was the final, definitive proof that modern warfare had transitioned from a test of individual soldierly courage to a test of industrial and logistical endurance. The era of the 19th century bolt-action infantryman, fighting with discipline and conserving his shots, was dead. The battlefield of the 20th century belonged to the side that could manufacture, transport, and expend the greatest mass of standardized technology. General George S. Patton Jr. famously summarized this transition when he called the M1 Garand the greatest battle implement ever devised. Patton did not praise the rifle because it was the most accurate weapon in the world, nor did he praise it because it was a work of fine craftsmanship. He praised it because it was rugged, simple, and allowed the average American conscript to project a devastating volume of fire. It was the perfect tool for an industrial superpower. The legacy of the tactical clash in the Pacific went on to shape the future of global military doctrine. After the war, every major military power abandoned the bolt-action rifle as a standard-issue weapon. The lessons of Guadalcanal, Saipan, and Iwo Jima proved that volume of fire and rapid suppression were the primary factors in infantry survival. The United States continued to refine the Garand design, eventually developing the M14 select fire rifle and, ultimately, the M16 assault rifle. The Soviet Union, observing the same battlefield realities, developed the legendary AK-47. Even the remnants of the Japanese military, reorganized as the Japan Self-Defense Forces, eventually adopted semi-automatic and automatic weapons, turning away from the legacy of the Arisaka. The bolt-action rifle was relegated to the specialized role of the sniper, where individual, long-range precision still held value. But the standard infantry fight had changed forever. When we look back at the Pacific War, the stark contrast between the Arisaka and the M1 Garand remains a powerful metaphor. It was a clash between the doctrine of spiritual willpower and the reality of industrial machinery. The Japanese soldier was expected to make up for his country's lack of resources with his willingness to die. He was given a rifle that was beautifully made, but slow and limited. The American soldier was viewed as a precious resource that must be protected by overwhelming firepower. He was given a rugged, mass-produced machine that multiplied his strength by 4. In the end, no amount of spiritual discipline could overcome the physics of a gas-operated piston and the logistics of infinite ammunition. The war was not won by the side with the most beautiful weapons. It was won by the side that could build them by the millions. If you found value in this deep tactical and strategic analysis of history's turning points, consider subscribing to the channel. It helps us bring you more declassified accounts and mechanical breakdowns of the weapons that shaped our world. Leave a comment below with your thoughts. Do you believe the M1 Garand was indeed the most important infantry weapon of the 20th century, or was there another rifle that had a greater impact? We read all your comments and look forward to the debate. Thank you for watching, and we will see you on the next battlefield. Peace.